Today we're going to start a new unit called Chemical Reactions. Until now, we have talked about elements, compounds, mixtures, but we have not yet talked about what happens when we actually combine different elements and compounds to make new products. So as far as writing an equation, there are two main parts. We have the reactants and we have the products. Reactants is basically substances we start with. This is what we start with. We take different compounds or elements, they rearrange, and you get new products. So this is what we end up with. So we start with reactants, substances we start with, they rearrange to make new compounds, and that's what we end up with. So let's take a look at an example. Well, actually, before we do that, look at law of conservation of matter, which we've talked about before. And what the law says is that matter cannot be created or destroyed. We're going to start with an example. So here's our example. If we start with iron and it reacts with oxygen gas, we get iron 3 oxide. So first of all, think about how would you write that equation. Iron is just Fe. Now it is a solid, so we're going to start putting things like solid, liquid, gas, and then the one other one that we have talked about is aqueous, something dissolved in water. Oxygen gas, you need to know, is naturally occurring diatomic, so it's O2 gas. And now we're going to form iron 3 oxide. So just to remind us, iron 3 means that iron has a +3 charge, oxygen has a -2 charge, and we crisscross it and we're going to get Fe2O3, and that's basically what rust is. So this is our equation, and we are going to see what that actually means. What does that actually look like? So let's say, so here's iron, here's an atom of iron. Now since oxygen is diatomic, it's going to look something like this, diatomic. And now let's look at what Fe2O3 would look like. Here's iron. I would have 2 irons and 3 oxygens. It's an ionic compound, so positive, negative, they are going to sit right next to each other, and that is Fe2O3. Now if you look carefully, what we have is one atom of iron on the left side, but we have 2 atoms of iron on the right side. Here I have 2 atoms of oxygen and I have 3 atoms of oxygen. Now we can't do that if we're talking about matter cannot be created or destroyed. So what we can really say is that you must have the same number of atoms of each type on both sides of the equation. Otherwise, the equation is not balanced. Otherwise, you are not following the law of conservation of matter. So let's see what we can do to make that equation be balanced. Let's see. There we go. All right, so we're going to talk about balancing chemical equations. So this is what we started with. And because I have 2 irons here, let's say we definitely need 2 irons on this side. Now if you look, we have 2 atoms of oxygen here, but I have 3 oxygens here, which doesn't quite add up. With something like this, think about the lowest common denominator between 2 and 3. Here I have 3 atoms, so the common denominator is going to be 6. So how could I make this side have 6 oxygens and this side have 6 oxygens? So if I was going to make this have 6 oxygens, what I can do is use three different molecules of oxygen gas. And because of that, I will need to have two different Fe2O3s. Otherwise, things are not going to add up. So if I look at this, now I have 1, 2, 3, 4, 5, 6 atoms of oxygen on the left side and 6 oxygens on the right side. However, now I have 1, 2, 3, 4 atoms of iron on the right side, but only 2 on the left side. So, wrong one, I'm going to add 2 more irons. This is kind of like a recipe. You're changing different amounts of things. You can't change this O2 into O6. You can't change this iron oxide into anything else. All we can do is change the amounts of things that we have. So the way you balance the equation is by putting a number in front of the formula of the equation to show how many of each you have. So in this case we have 1, 2, 3, 4. So I would put a 4 in front of Fe. I have 3 oxygen molecules, so I would put a 3 over here. And as a result, I make 2 units of iron 3 oxide, so I would put a 2 right there. That is how we balance chemical equations. Just keep in mind, we are changing the amounts of things. We are not changing the compound. We can change the amounts of reactants and products by changing these numbers, but we can't change the substances themselves, so we can't change the subscripts. Now, these numbers right there, these are called coefficients. And that's what we're going to change to make sure that the equation is balanced. Let's just look at overall the different balancing equation rules, and then we'll go from there for practice. So here are some of the rules for balancing chemical equations. First, you need to determine the correct formulas for all reactants and products. Write it in the form of an equation. Again, all the reactants, things that we start with, are on the left side of the arrow. On the right side are going to be the products. You want to count the total number of atoms of each type on both sides of the equation. That's what we're trying to make equal. If you have a polyatomic ion in one of the formulas, you can treat it as one big unit. And we'll see an example of this in just a second. You want to balance the equation one element at a time, and all you can do is add coefficients, add numbers in front of the formula. You cannot change or add subscripts because that changes the entire compound, which is not what we're trying to do. At the end, make sure to see and check if everything is balanced. And last of all, you need to make sure that the coefficients to balance the equation are all in the lowest whole number ratio. So now, let's see if you can do some examples. I'm going to give you the answers to these in class tomorrow. I do want to show you number 3 just because it has the polyatomic ion that I was talking about. So here I have 1 lithium, 1 lithium, 1 chlorine, but here I have 2 chlorines. So in order to do that, again, I cannot just put a 2 here because that changes the entire compound. The reason that formula works is because lithium has a +1 charge and chlorine has a -1 charge. So I can't change the formula. All I can do is I can put a 2 in front of LiCl. Now let's go to the next element, Pb, 1 Pb, 1 Pb. Here, instead of looking at nitrogen and oxygen individually, think about NO3, the whole nitrate ion. There are 2 NO3s on the left side and 1 NO3 on the right side. So you can treat that as one big unit. So here I have 2, here I have 1, so the way I can balance it is by putting a 2 right there. Now again, you can do it by balancing nitrogen and oxygen individually, but you can also treat it as one big unit. Now let's just go back and check to see if everything works. I have 2 Li's, 2 Li's. 2, that number counts for everything in that formula. So 2 Cl's, 2 Cl's, 1 Pb, 1 Pb, 2 nitrates, 2 nitrates. So that's how you would balance the chemical equation. Your homework for tonight is to balance these two equations. For this one, you would first have to come up with the correct formulas of each one. So again, I will get you started. I'm going to start with aluminum. Aluminum is +3. Sulfate is a polyatomic ion. Sulfate, if you look up, is -2. When you crisscross it, you would get Al2, SO4, 3. Then you would continue on to lead 2 chloride, and then as a product you would get these. So again, just to get you started, I would like you to come up with the rest of the 3 formulas and try to balance the chemical equation. See you tomorrow.